Hello, today we are going to start a new topic called as sufficient condition for f of z to be analytic. So first let us write the statement. The sufficient condition for a function f of z equals to u plus iv to be analytic at all the points in a region R. So we are having two conditions. One is delta u upon delta x is equals to delta v upon delta y, or delta u upon delta y is equals to minus of delta v upon delta x. Second condition, delta u by delta x, delta u upon delta y, delta v upon delta x, delta v upon delta y are continuous functions of x and y in a region R. So let us start our proof. So as f of z is a single valued function, so we will have delta u upon delta x, delta u upon delta y, delta v upon delta x, delta v upon delta y at each point in a region R. Then the CR equations are satisfied by Taylor's theorem. CR's is Cauchy-Reimann equation. So our f of z becomes f of z plus delta z is equals to u in a bracket u plus delta x, y plus delta y. Same way, plus iv, x plus delta x, comma, y plus delta y. So in the next step, what I'll do, x and y terms together, Similarly for iv also x and y terms together, and I'll separate the delta terms and the x and y terms. So similarly, u is equals to x comma y plus delta u upon delta x, then next this one, delta u upon delta y into delta y. This is actually a differential form, partial differential, and this is delta, this is dou, and this is delta, plus iv, again same thing, x plus y plus delta u upon delta x into delta x plus delta v upon delta y. So next step is equals to, so we are getting x comma y plus iv x comma y. Here it is also x comma y, same way, plus f dash we will be getting limit of del next we will be getting delta u upon delta x plus I delta v upon delta x plus delta u upon delta y plus I delta v upon delta y into delta y. So dot. So we are getting the higher powers again. So that previous term, so we will be substituting it as f of z plus delta u upon delta x plus I delta v upon delta x into delta x plus delta u upon delta y plus I delta v upon delta y into delta y plus dot. So we are ignoring the terms of second power and higher power. So next term what we will get, this f of z we will be taking it to the LHS. So what we will get is delta z, f of z plus delta z minus f of z is equals to, this terms will be remaining. So these dots we will be taking out. So delta u upon delta x plus I delta v upon delta x, so delta x term plus delta u upon delta y plus I delta v upon delta y into delta y. So this we will be marking it as a equation number 1. This whole will comes out to be an equation number 1. And we have the our same CR equation. So in CR equation, what terms we are having it together? So delta u upon delta x, delta v upon delta y, then delta u upon delta y is equals to minus of delta v upon delta v upon delta x. So replacing these terms, that is delta u upon delta y and delta v upon delta y by minus delta v upon delta x and delta u upon delta x. So in these terms we are replacing it in the equation number 1. So we will get something like this. So which terms we will be getting? So this is LHS. Now RHS becomes delta u upon delta x plus I delta v upon delta x into delta x plus, so minus delta v upon delta x. So we have replaced the v term, these terms in this equation. So plus I delta v up delta u upon delta x into delta y. So next step, what we will be doing, delta u upon delta x plus I delta v upon delta x into delta x plus, so we'll take out I as common term. So I delta v upon delta x plus delta u upon delta x into delta y. So next step, this term and this term is common, so we will take it out. So what we will be getting, delta u upon delta x plus I delta v upon delta x into delta x plus I delta y. Similarly, this term is what? The delta z. So delta u upon delta x plus I delta v upon delta x will give me delta z. Okay, so our next substitution, so that delta z we will be taking it to the LHS and we'll solve the further equation. So how we'll solve the further equation? So we will be getting this is equals to delta u upon delta x plus I delta v upon delta x. So applying limits on both the sides, limit of delta z tends to 0. So f of z plus delta z minus f of z upon delta z, which is equals to delta u upon delta x plus I delta v upon delta x. I hope up till here the terms are clear to you. So next step, it will be like this will be, what is this? This will be f dash z, which is equals to delta u upon delta x plus I delta v upon delta x, or f dash of z is equals to delta v upon delta y minus I delta u upon delta y. So we have proved our proof, hence proved. So which all conditions you should remember for this? First point is CR conditions. CR conditions are necessary, but those are necessary but not sufficient for analytic function. Then CR conditions, they are sufficient if the partial derivative are continuous. If a function is a analytic in a domain D, then u comma v satisfy CR condition at all points in D. So we have completed with the proof and the necessary conditions required. Now let us solve one problem. So determine whether 1 upon z is analytic or not. So let us write the analytic equation. W is equals to f of z is equals to u plus iv is equals to 1 upon z. Okay, so what is u plus iv? 1 upon I plus iy. So I can write this equation further as 1 x minus iy upon x square plus y square. Now I will equate the imaginary terms, real and imaginary terms, equating real and imaginary parts. We will get u is equals to x divided by x square plus y square. Similarly, v is equals to minus y upon x square plus y square, or du by dx is equals to x square plus y square minus x into 2x divided by x square plus y square the whole square, the whole square, and which we will be getting as x square minus y square minus x square divided by x square plus y square the whole square, or you can say again the du by dy we will be getting as du by dy is equals to minus of 2xy upon x square plus y square the whole square. Then we will be getting the dv by dy is equals to 2xy upon x square plus y square the whole square. This is dv by dx, and dv by dy is equals to x square minus y square minus x square divided by x square plus y square the whole square. So this we will be getting. So then, as we know, du by dx is equals to dv by dy, as we know, and du by dy is equals to minus dv by dx. Thus Cauchy-Reimann equation is satisfied. So as you can see here in this part, this is du by dx, and here in this part dv by dy. So this term and this term is same, okay, and same way du by dy and minus dv by dx. So this term and this term is same, so we are getting a negative term here. So this equation, this terms and this terms are satisfied. So as a result, so CR equation is satisfied. So also the partial derivatives are continuous except at 0 comma 0. So therefore 1 upon z is analytic everywhere. It is analytic everywhere except at z is equals to 0. Also dw upon dz is equals to minus 1 upon z square. Thus again shows that dw upon dz exists everywhere except at z is equals to 0. Hence 1 upon dz is analytic. It is analytic except everywhere except at z is equals to 0. With this we have completed the one proof and one example. So we have started with a one proof, that is sufficient condition for f of z to be analytic. So which are the sufficient conditions we will require, and we have started the statement and the proof. So we have completed our proof and we have started one example, determine whether 1 upon z is analytic or not. So we have successfully got a proof for this. Then now I'm going to start a new topic called as the CR's equation in polar form. So it's just a simple two-line proof that CR's conditions in polar form. So let me start that proof. CR's equation in polar form. So in polar form, how do you represent this CR's equation? So which is my polar values? So first is, so let me write this one, that is delta u upon delta r is equals to 1 upon r delta v upon delta theta. This is my first point which I need to prove. Second is delta u upon delta theta, which is equals to minus r delta v upon delta r. So let me start this proof. So proof will start like this. So we have to get the value of x and y, and then we'll require the value of r also, and the polar representation of the complex numbers. So what is x? X is equals to r cos theta. What is r? Y? Y is equals to r sin theta. And u is a function of, so u is a function of x and y. So what is z? Complex number representation, z is equals to x plus iy. So which is equals to r cos theta plus I sin theta. So which is also equals to r e raised to I theta. So u plus iv form is equals to f of z, or you can write this thing as f of r of e I theta. So let me mark this thing as equation number 1. Now differentiating equation number 1 partially with respect to r. See, now we will be differentiating equation number 1 with respect to r, then with respect to theta, and then substitute these values and see what we will be getting. So with respect to r, so now it's just a simple differentiation, and you'll get good marks for this equation, for this question. So now we just substituted the value of x, y, and then z. This is a polar representation. Now let's see how we will move further. Now differentiating equation number 1 with partially with respect to r. So we will be getting, so what we will get, du by dr plus I dv by dr, which is equals to f dash of r e I theta into e of I theta. So this I'll mark as equation number 2. Now again differentiating 1 with respect to theta. So what we will be getting, so du by d theta plus I delta v upon delta theta, which is equals to f dash of r e I theta into I. Let me mark this as equation number 3. Now what I'll do, as I told you, substituting the value of f dash r e I theta into e I theta from where? So from 2 in 3. So this value I will write it down here. So what we will obtain, so we will get delta u upon delta theta plus I delta v upon delta theta, which is equals to r delta u upon delta r plus I delta v upon delta r into I, or delta u upon delta theta plus I delta v upon delta theta, which is equals to IR delta u upon delta r minus r dv upon delta r. I hope up till here it is clear how we have done the substitution. So equating real and imaginary parts we will get. So equating real and imaginary parts, we get delta u upon delta theta is equals to minus r delta v upon delta r, or delta u upon delta r is equals to 1 upon r delta v upon delta theta delta theta. Thanks for watching.